Okay. B, that looks like. Well, let's see. If we do the math, we can do sum the forces in the Y. So we got negative 28 kips, which is 1 kip per foot times 14 feet. So right here at 7 feet, you got 14 kips, right? So 14 plus 14 is 28, plus AY. Therefore, AY equals 28 kips up. We could do a moment there. We've got 12 kips. That's going positive, right? At, what was that, 18 feet? Plus 2 at 8 feet. Plus 14 at 7 feet. So the bending moment there should be 330. These are kips, aren't they? I did it again. I put pounds. Kips. Feet. Okay, so that'll be, we'll use that to check our work here in a little bit. So then what I did was I said, okay, so I need to go and look at this right at this 2 kip force. So I'll go in there and say I want to look at 10 feet from the left. And only look at what's going on to the left, if you will. So I'm just looking what's going on right there. So I've got a 12 kip force, right? Then I also have, this one would really trick you up if you weren't careful. You got 6 kips, and that distance is 3 feet, right? And this distance is 10 feet. If you'd have to be real careful because that 6 kips is in there, right? Because see, there's 6 feet of this that still has evenly distributed load. So that's why that's there. So the shear in that case is going to be minus 12 minus 6. So minus 18 kips. And we could do a moment there if you want. We got negative 12 times 10 feet minus 6 times 3 feet. And you find out that that's 138 kips feet. Otherwise I put pounds in there every time I put pounds in there. That's not real critical right now, that moment part isn't, but it can help us. So then I want to look at that 10 feet location and look to the right of that. So what do I have going on now? Everything's the same there, right? Almost. Yeah. This is 12. And there's still the 6. But then you get to put the 2 in because you're looking to the right of it. So the shear minus 12 minus 6 minus 2, which is what, 20? Yeah. And I made that 20 pounds. Minus 20 kips. The moment is still the same. Because you can't count the 2 because there's no distance, right? Now again, I do those because that's a location where there are going to be some changes. So oh, you know what? Yeah, that's right. Never mind. Yeah, that's the critical points, right? Because if we look, the critical points that we're going to look at are going to be locations where there are external forces. Okay, and you know, these orange forces, if you will, plus, I mean, you can't forget the evenly distributed load, but things are happening at those locations where you've got those concentrated loads. So then my shear diagram is going to look something like this. Let's see, I really, nice if I could get that. I can't do it though. Well, let's see. I'll transfer it down. How's that sound? Let's see. We're at the end right here, and there. Let's say. Give myself some room. Okay, so I think 0 right here. All right. So let's see. The first reaction is out on the end. It went down 12, didn't it? Minus 12. It stayed the same for the first 4 feet. I should have transferred all those down, shouldn't I? So let's see, that's going to be about right there. And there's another force right in there, I guess, is it? Or was it a little farther, I guess? Yeah, that's right. Okay, so let's get that eraser out there and erase some of that. Got a little bit sideways, didn't I? Okay. Try it again. So it started out, it went 12. Stays the same for 4. Then what's it do? Over here, it goes to 18. Okay, and that's going to be a straight shot. Then it goes down to minus 20. Right? That's where these two shear values come into play. Then it goes down even farther. That last one was 28, wasn't it? It's 28. Well, yeah, the AY is 28. So okay, and this was minus 12 here. So it goes down 12, stays the same. Then it starts changing until it gets to 18. Then it goes down 2 more based on the input force of 2 kips. And then it starts changing again on that slope based on the evenly distributed load, right? Evenly distributed load in between, there's a 2 kip force being applied. So that's how you get that offset. Then I do my areas. $12 times 4, wasn't it? 48. 12 times what? 6? 72. 12 times 6 divided by, yeah, let's see, was it 12 times 6? No, 6 times 6. This distance here is 6 feet. That's 4 feet, and this is 8 feet. So it's 6 times 6. It's the difference between these two, right? Divided by 2. So 6 times 6 is 36. Divided by 2 is 18. 8 times 20 is 160. And then what? 8 times 8 is 64. Divided by 2 is 32. Now, coincidentally, this last one here, well, I don't want to say that. Okay, so then we do our moment diagram for that. Looks something like this. Well, the first part of that is evenly distributed, or excuse me, is just a concentrated load, right? So it goes from here down, and that's minus 48. That's that area, right? The next point that I want is along this line. Drops straight down, right? It ends up being minus 138. I just screwed that up. Minus 138. Again, how do we get that? Well, it was the 48, if you will, plus 72 plus 18. Should be 138. 8 and 8, 16, 18, 5, 6, 13. Of course, it's all negative. Now that's going to be a evenly distributed load, so that's going to have an arc to it, isn't it? Then the last one is this 138 plus 160 plus 32. Those are all negative. Punch all those numbers in, you should get 330. So, negative 330. Again, that's gets an arc too. And coincidentally, that 330 matches up to our original 330 we had up here. Okay, so again, those weren't, the moment diagrams weren't asked for, but I felt like I should show you those. Jabril? Sure.
Would it matter if you split the shear diagram differently? I think that's what I split it differently, not thinking it wouldn't matter.
What do you mean by split the?
Like I drew, like, I don't know why I did, but I drew my dotted lines to find the area of this direction.
Yeah, you should still be able to do that. So the question was, can I?
Work out differently.
It shouldn't work out differently.
Well,
The question was,
with the 160.
can I do it this way? You don't end up with the 160, but you should end up with this whole thing here. Then you'd have this 18 plus this value here plus this plus that 32. So you just essentially
Yeah. 12 times 14.
12 times,
6 and 8.
no, would have been 12 times 18. Would have been 12 times 18 when it got you this whole piece there in the bottom.
Yeah, sorry, that's what
Then you would have had this small piece here, which would have been 6 times 8, right?
Yeah.
48, plus that. and then you would have had this still in here.
Yeah, 2 times 8.
Yeah. Plus the 32. It should still be the same area. I mean, no matter how you split it up, unless you do your math wrong.
But then I transferred the number that I got for 12 times 18 down to where you put your negative 48.
Oh, well, that won't
That's
work.
what I'm saying, that's, you
Yeah.
don't end up with the same.
No, you can only, when
The area would
you,
be
to
the
find the 48
Yeah.
here, it's this area right here.
Exactly.
To find the 96, is that what it was? Or not 96, the 138, it has to be this whole area right here.
Yeah,
So you can't add that in there with it.
yeah, that's where
So that's probably why it's better to
yeah,
split it
why
up
you
like
did
I
what you
did.
Exactly.
Yeah. So yeah, we'd take that out and that out. That's more realistic.
Yeah.
That's okay, that's why we go over this. You good, Jabril? Okay. Did I tell you to do 16? Good, because we had plenty to do, and I had originally had that marked on one of my sheets, but I didn't have it on both of my sheets. So 17 was the next one, right? A only.